Now today we are going to discuss about the electric dipole. A electric dipole can be defined as a pair of equal and opposite charges which are separated by a small distance. Now we talk about the dipole moment. The dipole moment of electric dipole is a vector whose magnitude is either charge times the separation between the two opposite charges, and the direction is along the dipole axis from negative to positive. If you see that the direction of this dipole moment is from negative charge q towards the positive charge q here. Now the dipole moment can be calculated by this formula here, that is p vector equals to q into 2a. Now this dipole moment is a vector quantity here. The SI unit of this dipole moment can be given as coulomb meter. Now we are going to find out the electric field at an axial point of a dipole. Now if you see that minus q and plus q which are separated at a distance of 2a forming a dipole, and the dipole moment is given by p which is acted towards the direction from minus q to plus q. Now we are going to find out the electric field at p. Electric field at p due to the charge plus q is given by E suffix plus q, and electric field at p due to the charge minus q is given by E minus q, basically E suffix minus q here. Now the electric field at an axial point of the dipole we are going to consider here. The electric field due to the charge minus q at point p is given by E suffix minus q vector is equals to, that is again minus q upon 4 pi epsilon naught q r plus a raised to the power 2 p cap. P cap is a unit vector, and this distance of this charge minus q from the point p is given by a plus r here. Now we are going to find out the electric field due to the plus q charge at point p, that is E vector suffix p plus q equals to q upon 4 pi epsilon naught r minus a raised to the power 2 p cap, that is towards right. Now hence we are going to find out the resultant of the electric field at p, that is E vector axial equals to E plus q plus E vector minus q here. There's plus q and minus q are the suffix of this electric field E vector. Now we have this relation here. Finally we get the formula after calculation, that is E axial is equals to 1 upon 4 pi epsilon naught 2 pr upon r square minus a square raised to the power 2 p cap. That is a p is again a unit vector, and hence p, since p equals to q into 2a dipole moment, so we can put this value of p here or we can take it if r is much larger than a, in that case a square can be neglected, and in that case we have this formula of E axial, that is equals to 1 upon 4 pi epsilon naught 2p upon r cube p cap, and that is towards right direction. Now we are going to find out the electric field at equatorial point of a dipole. Now if you see that again, now here that plus q and the minus q are forming the electric dipole. They are equal and opposite charges, and they are placed at a distance of 2a. That O is the midpoint of this line joining the plus q and minus q here. That is, you can say that the distance AO is equals to small a and OB is equals to this small a again. Now from O, the point P exists at a distance of small r. Now in that case at point P, the electric field due to the minus q is given by E suffix minus q vector, and its direction is towards the minus q here. As we are going to place a test charge at P, so this direction of electric field is towards the minus q here. Now, in that case, the electric field due to a plus q charge at point P is given by E suffix plus q, and it is direction away from the this plus q charge. Now we are going to find out the this electric field in this due to this equatorial position, and we are going to find out the we are going to calculate it. Now, if suppose this PB makes an angle theta with the AB, and again equatorial, we are talking about the equatorial point at dipole. Now, if this we are going to consider this angle PAB and PBA is theta. In that case, we are going to take the horizontal component of these electric fields due to this minus q and plus q charges. So we get the sum of this horizontal component here, and that is given by E equatorial equals to minus E suffix minus q cos theta plus E plus q cos theta P cap. Now, in this case, since E minus q equals to E plus q, so we have this value here minus 2E minus q cos theta P cap. Now we are finally we are going to put the value of E minus q here. That is given by this formula here, 2 into 1 upon 4 pi epsilon naught q upon r square plus a square a under root r square plus a square into p cap. The final result of this electric field due to equatorial position after calculation is equals to minus 1 upon 4 pi epsilon p upon r square plus whole square raised to the power 3 by 2 p cap. Now we have this value here. If r is much larger than a, we are going to neglect this a square here, and finally we get the value of E equatorial equals to minus 1 upon 4 pi epsilon naught p upon r cube p cap.
Now student, we are going to discuss about the torque on a dipole in a uniform electric field. Now suppose if an electric dipole which is formed by two equal and opposite charges, that is plus q, placed at a distance of 2a, formed and it is placed in a uniform magnetic field, it will experience a force due to this uniform electric field. Now if suppose the dipole moment of this dipole is taken as P equals to Q into 2a, now the force exerted by the this uniform electric field on charge plus Q is given by Q into E, which is along E. Now the force acting on the charge minus Q by the uniform electric field E is given by minus QE vector, which is opposite to the uniform electric field E. Now the total force acting on the dipole is the sum of this plus QE minus QE, that is equals to 0. As the torque acting on the this electric dipole is the product of either force and perpendicular distance between two forces. Now if you see that the perpendicular distance between these two forces is given by 2a sine theta, and the either force we can take it as QE. Now finally we get the torque, that is equals to PE sine theta. As the direction of the torque is perpendicular to both P and E, so we can write this as tau vector equals to P vector cross E vector. Now if you see that this torque is perpendicular to the this dipole moment and this electric field vectors, so we can write torque equals to that is torque tau equals to tau vector equals to P vector in cross E vector. Now when this dipole is released, the torque tau basically tends to align this dipole along the uniform electric field E. For that the angle becomes theta becomes 0 degree. In that case tau becomes 0. That means if you see that here, the torque tau becomes 0. That means the torque acting on the dipole becomes 0 when it is aligned along the electric field, uniform electric field E. Now if torque tau now we are going to calculate the torque tau, that is when this electric dipole is placed perpendicular to the uniform electric field. In that case this tau is maximum, that means torque is maximum when it is when dipole is perpendicular to the uniform electric field. We can see that in that case the angle theta becomes 90 degree, and we put the value of this theta 90 degree in the equation we find out in previous slide, and in that case it becomes PE, tau maximum becomes PE. Now if you take the value of uniform electric field E equals to 1 unit and theta equals to 90 degree, in that case tau equals to P. On that basis we can define the dipole moment, that is, it is defined as the torque acting on the electric dipole placed perpendicular to the uniform electric field of unit strength.